Okay, our last talk for today is going to start in 30 seconds. But before that, I just want to announce that if you have any question during the talk, just type it on the chat box and then we'll relate it to the speaker at the end of the talk. Additionally, we also encourage to visit the booths of our sponsors and really have the chance to win lots of prizes, and also check out those that are hiring for positions if you're interested in job opportunities. Okay. Now it's time for our last talk. The title of the talk is End-to-End MLOps for Computer Vision. It will be given by Ashwini Badgujar. Ashwini is a machine learning engineer at Impulselogic, and he has been in machine learning domain since the last 3 years, working on various research and commercial projects. And he has been part of research teams at University of San Francisco with a focus on machine learning problems in NLP and computer vision. So for the next 30 minutes, Ashwini, you have our attention. At the end of the talk, we'll come over with a question. So enjoy your talk.
Hello, everyone. Nice to see you all here. I am very glad that I am speaking here today for end-to-end MLOps for computer vision. To give you a bit intro about me and what I do, I am Ashwini Badgujar and I work at Impulselogic as a machine learning engineer. And then I recently joined Fourth Brain as a training associate for their MLOps cohort that happened. And therefore, I think I have been working in the MLOps domain, not only through the projects, but through the teaching perspective, where I am, trying to help people understand what MLOps is. And you guys can join me on LinkedIn. In the link below, you can just directly search Ashwini Badgujar, and I think you can find me there too. So let's start with the talk today. Firstly, what MLOps is, I wanted to give a quick intro or a quick overview of what MLOps is in the, say, computer vision domain. More specifically here, I'm talking about neural networks, say image detections, object detection, image classification, and these kind of things. And it is very important to understand that why MLOps matters. There are different things that people work on today. They do the data processing, data pre-processing, analysis, model building. But then after that, it's very important to scale the model. 1, second, monitor it. 3, have those revisions, because we all know that, in machine learning, we all do the modeling part and then we keep revising our models. The data, gets old. So we kind of refresh it with the fresh data and those things. So it's very important to, understand where actually MLOps lies. So if you see on the left side, the traditional software says that it's a code, for example, that you usually use and then you release it. But it is a bit different in machine learning domain. How it works is that you have a code that kind of builds the model, and then there you have data, and then you have parameters. Once you have the whole thing, then you kind of build a model. Now, building a model also has its own parameters or its own attributes. Say, fine-tuning the model, selecting which model is better, and then checking which one is performing at scale. That is another thing. And then once we, look at some of these parameters, that is when we release the model or the machine learning model to production. And again, there's offline and online training too. But thinking of all together, it's all about training and having models in production at scale. So yes, it's very easy in order to get, building a model and then deploying it on one server, or, just getting a prediction out of it, but scaling it to large scale. And say here now that we are talking about computer vision, talking it or seeing it from the perspective of computer vision, or say images, which kind of has complex data. And of course, as we know, deep learning models have these deep layers. So, number of layers that we have, and then the data that we have. So neural networks need a lot of data. So thinking of all these things, MLOps plays a vital role in scaling your models, as well as tracking the implementations and experimentations. So how do we work on that? first, how traditional software works is it kind of builds something, say builds a software, you kind of build a script, write a script, and then it kind of works on a server. Rather than that, how machine learning model, or rather computer vision model works is, once you have a model, you kind of train it, you optimize the hyperparameters, and then of course, given that the number of layers that we have in deep learning network, neural network, and then the number of hyperparameters that we tune in, it requires more and more GPUs. I am pretty sure that it would take, say, days or months to train a simple, say, CNN or RNN, take ResNet, or take an LSTM model, which kind of takes a long time to train on a CPU, versus when you put it on GPU, it's much easier, and then is less time consuming. The other thing about GPUs is that not only it just saves the time, but it also kind of distributes your training. And that's where MLOps comes into picture of, it kind of trains it faster, trains it easier, and then having that distributed manner gives you output at in seconds, rather than working on, say, in days or months. Here's a good architecture of how and where MLOps lies. So the whole, as you can see in the picture, the data sourcing, the data labeling, the data versioning are all three part of data processing or pre-processing. Whereas the model management that you can see, the experiment tracking is another part of model management. So once you create a model, that's model architecture, you train it and then again do the evaluation. If it's good, great. If not, you again go back to model architecture, again change it, again train it. So that's the experiment tracking part, wherein you experiment more and more, and then make sure that whatever computer vision problem that you're trying to solve has this good classification or object detection done. Once you have that, you go to model versioning, wherein you check what was, you kind of keep the latest and the good performing model with your latest versions, and then the model is deployed. Again, here are few other things that we look into. Once you're done with your model deployment, it is also important to scale your hardware. One, as I said earlier, is converting it from CPUs to GPUs, and then the other thing would be, of course, checking your hyperparameters and tuning them. And then once that is done, again, you go back to scaling hardware, and then the whole procedure of model architecture training, the whole cycle repeats itself, goes back. And then if the model is deployed correctly and is working at scale, then you go to prediction monitoring, wherein you see if your model is predicting correctly, and if it is predicting correctly, how am I monitoring that models. And so that's one part of what MLOps is and where it lies. Why it is important is another thing. So here you can see the whole diagram of what all things come into a computer vision problem, or a neural network problem altogether. You kind of use automations, configurations, data collections. This is one part. And then there's another part which kind of serves your infrastructure, your neural network, your monitoring. But then here's the thing. Your ML code that we are actually working on, or your actual model that you're dealing with, it's a small part. It's a small part in the whole ocean of configurations, tunings, and resource managements. So once you have good data, and then once you have good model, it is also important to deploy it correctly. Not only deploy it correctly, but also deploy it with scale. And that is what is more important when it comes to prediction part, because once data analysis part, the data collection part, and then once you're done with model building, it's more important to serve the data faster. Because I cannot sit on a website, say, which kind of detects something and then takes, say, a minute or two, or say, even for that matter, if it's half a minute, or for me, even that would be a bit uneasier for me. So it's important for your models to scale, and that is why MLOps is important. Now comes how it is implemented, and this is more specifically towards computer vision that I'm talking about. We know that computer vision, as in neural networks here, have images, or they have a set of images. So we usually work with images and videos in computer vision in neural networks. And there are various problems that we solve on images and videos. Now, videos is another, just a stack of images. And then what you usually do is you usually, we know that it's all a complex data set because it kind of converts itself to numbers. And then there are, say, millions and billions of images that you deal with in one time. Also, the other thing is that we usually work in batches when we are working with computer vision, or rather, when we are working with images or a stack of images. And therefore, it is important that we do not have bottlenecks when an image is passing through the pipeline. So there are multiple MLOps implementation that usually people do. The first one would be the manual process. Second one would be the pipeline automation. We'll talk about this in further slides, but just to give you an overview, there are three type of MLOps implementations that people do. One is manual process. Second one would be ML pipeline automation, wherein we are just automating or say trying to update the ML pipeline that we have. And then CI/CD pipeline automations, which is say continuous integration and deployment, wherein we are not only updating the pipelines but also updating our ML ideas. And I'll shortly let you know how it is done. So for the first one, manual process, what we usually do, we have manual scripts. So say a Python script or a Python script or a Jupyter notebook, which kind of takes the data in, pre-processes it, and gives it to the model. And for this one, what we do is we assume, and this is mostly with the startups, that we assume that there would be one model that would be working or serving altogether to all the requests. One. Second, there are no frequent release iterations. So as I said, we often believe that there won't be any releases in the models, there won't be any iterations, and therefore we go with manual process. Third one, there is no continuous integration. So as we are not iterating the models, we are not integrating them to the current, say, code commit or current repository. And then no continuous deployment, because we are anyways, if we are not integrating, we do not have a new code that is working on a new idea, we do not deployment. And then here, the deployment basically refers to just the prediction service. So the only model, or say fewer models that we have. I won't say that it's just one model that the company is working on, but mostly it would be fewer models with some small scale data, and which can be served on, say, one server or at most two. And then it has lack of performance monitoring, because you do not have 1,000 servers to monitor your model. It's just one or two server that you're monitoring, and therefore it's not, say, that scaled and that active. And that's how manual process is or works in MLOps. And here's a quick diagram of what we talked about, the manual process that we are dealing with. We start with, say, data analysis, extraction and analysis. And then once that we have that from the offline data, we have some manual experimentation steps, wherein we do prepare the data, we do the model training, and then we evaluate it. Once we have the evaluation done, we directly put that model to a model registry. Now, here's another thing about working with manual processes. Since we do not have many models to work on, it might be just one or two model in your model registry. Again, we do not need to scale it, because, we know that the data is not too much and it's not highly scaled. And then once we have that, we kind of do model serving, which is, again, we have some services, say, using REST and using Flasks or fast APIs, and then we write the services, the APIs, to predict what our output, what our model is actually trained on. So this is a manual process of how an image goes through in a pipeline. Let's go to ML pipeline automation. Now, what this means here is I am trying to change or update the pipeline that I'm using. So it might change the data processing, the data analysis part, and then some of the model training part, though I'm not training the model altogether. So we are not bringing in a new idea here, but what we are doing is we are just updating or automating the ML pipeline that we have. we do experiment. Here's the thing about model pipeline, ML pipeline, that we usually do more experimentation with this models. And then we usually, the actual usage of why people usually automate their pipelines is because they have data coming in. And so as the current data gets older, they kind of train their model with fresh data that is coming in. And because of that, there is continuous delivery of models. And since the new data is coming in, the pipeline is getting updated every time, and then the model is getting trained with fresh data every time. There is a new deployment. So I won't call it a new pipeline, but a new updated pipeline, which is deployed every time when a model with, say, fresh data or new data comes in. And so here's how that looks into diagrams. So we start with, again, we have data analysis. This is all offline extraction from here, from the feature store. We do the same experimentation here. So there's data validation, preparation, model training, and then evaluation, validation. Once we have that, we again go back. If we need to have some better ideas or some better models, then we again do model analysis and go back. But as you can see, that source code goes into source repository, and that is where the pipeline is built. Once we have the pipeline, here's the thing: we again have this automated thing. What it does is it fetches the images here into batches, and then kind of creates this whole automated pipeline. This here, what you can see is experimentation, but this one here is the automated pipeline that we're dealing with. And once we have the model correct and validated, we put it into the model registry, which then performs as a trained model and then goes to model serving with the prediction services. And this is again the metadata store, which stores some of the ML hyperparameters or the tuning parameters that we are using. So that's how ML pipeline automation looks. And then now let's talk about CI/CD pipeline automation, which is continuous integration for continuous deployment. Here, what we are trying to do is not only that we are automating the whole pipeline, but we also try to bring in the new idea or say some code change that we are doing in the model. So how this looks is there are a few other things that come into picture when we are dealing with CI/CD pipelines. One, because it is continuous development and experimentation, what happens is when you are done with one model, you again go back and kind of try to update your model for better performance. You might take a new model. So this is more about getting into new ideas, new ML ideas, and trying different models. And then you kind of create pipelines for them. And then these pipelines have this continuous integration and delivery. Now, how it works is when a new data comes in or when a new batch of images comes into picture, it kind of automatically triggers the data processing. So for example, here I'm just taking an example of AWS S3 buckets, say writing a Lambda function, which says that once an image is into an S3 bucket, it kind of goes to, say, a code commit repository wherein it pre-processes the image, and then there might be a Sagemaker tool that is working and that is training the model, predicting again, and then that is how CI/CD pipelines actually automatically trigger the whole pipeline when new data comes in, and it actually kind of also update the new models that we are working with. And therefore, this kind of feels a continuous delivery. So there's no you kind of train the fresh data every time that you have a new model. One. Second is whenever you're updating the pipeline, you're not only changing the model with the fresh data, but you're also changing the model with the new idea that you have, say a better performing model. And that's how CI/CD pipelines work. And here's another example of how a CI/CD pipeline would work. So we saw in the earlier example that we had this orchestrated experiment that we were doing, just testing and seeing which is the model that performs the best. So once you have the best model performing, the source code goes to source repository. That is wherein you package the whole pipeline. Or say, for example, here I would give an example of say covering your code or dockerizing your code into a Docker image. And then once you have packaged that, those packages are going into deployment, into pipeline, CI/CD pipeline deployment. And then once you have that, again, your feature store is getting your automated pipeline here. The model is stored into the model registries, and that is what serves as a trained model. Now, what differences it makes is, once my new data comes into the source code, what it does, it changes or updates the source repository, again builds and tests, packages the new source code that I have, and then those packages again go with the whole pipeline, building a new model. And that is how, again, you kind of serve the model. And that is how prediction services work. So that is the difference between the three ML ops deployment or implementation that we work on. And now, how, like, we talked about few of the how images work, but then here is how actual computer vision or say neural network pipeline would look like. Say you have an input data. Now this is more focused towards how an image would go through a pipeline. One is you have an input data which is images, in case if it is a classification problem or if we are dealing with say standard images. Otherwise it would be image frames, which would be image frames in case of videos. And then we do some pre-processing, say scaling, changing color, some data augmentation part there, changing the size, pixels of the data, the images that we have. What are the areas of interest that we are using? Say, is it a classification problem, a object detection problem, or image segmentation problem? Once we have that, we do feature extraction, wherein we have these first few layers wherein we are extracting features, and then the last part kind of are used as classifiers or detectors, which detect or classify the images. Once we have that, we have the predictions. That is where you recognize the object, or the feature matching part, the classification part. And the action here says that once you have that, you kind of start predicting your images. And that's where the fast API or the flask API come into picture, and they kind of have these APIs which kind of hit your model and hit your service actually, and then give you the output. Now this is from the computer vision or say neural network point of view. Let's see how it looks from the MLOps point of view. So this is an example of Amazon Sagemaker, wherein so the earlier part that you saw was in the images, was in the neural network format. But how it looks in the CI/CD pipelines is you start with the model building, and then that is, so there are different sections to Amazon SageMaker 2. One would be model building that you can see here. And what it does is it just builds your model and then trains it for the existing data that you have. Once you have that, you again do the retraining just to see if your model is performing good. I mean, this is again the comparison or the monitoring of the models and how they're performing, their performance check. Once you have that, you kind of put all your models to the model registry. Now here you can see I have one model with 2 versions and then model 2 with 1 version. Now this kind of helps me to keep track of my experiments, at the same time to keep track of to keep track of how my models are performing. And then once I know the one that is from my model registry, which is a central store, once I know the model that is performing the best, I kind of deploy it again using the SageMaker. So this is one way of looking at how images or how neural nets work in Amazon SageMaker, or how they are deployed there. This is a smaller and a basic version of a deployment, but not everything works into a SageMaker maybe. So here's another example, and this is another end-to-end pipeline that we are seeing here. Yes, Amazon SageMaker plays a big role, but there are other services that are provided by AWS which we can use. For example, if you start here, of course, this is the whole thing wherein you are building the model. So you kind of start with, say, Amazon Event Bridge, which kind of keeps track of your events in the applications. And then code commit is another, just like you can visualize it just like a Git commit, wherein you are posting or you're updating your code. So this kind of keeps all your model code or all your artifacts or all your building specs in the repository. Once you have that, it kind of builds your code based on the code build that we have, the code commit that we have. And then it kind of executes the pipeline. Now, the earlier picture that I showed was a smaller version wherein we are just using the SageMaker to train, pre-train, say deploy, and just predict, or say do some storage part. But here, the picture is a bit wider and a bit detailed. So how you deal with it is, once you have your code built ready, you kind of do the whole model build workflow, which is again pre-processing, training, and then again training, if training and seeing if your model is performing great. If not, you again go back and change. So that's one thing. And now this whole thing becomes CI pipeline, which is continuous integration, because once you put something into your code commit, it kind of automatically triggers the whole pipeline altogether. And therefore, this whole thing is known as AWS code pipeline. Now, this is more towards AWS that I'm talking about, more of the technical softwares that we're talking to deal with how to deploy or implement MLOps here. And so once we have the model, we again register it into the registry, which is again here. So this is SageMaker model registry. Once we have that, we kind of deploy. Now this is, so we hear this CI CD pipeline. So this is the CI pipeline that I'm talking about. And then this is here, the CD pipeline, where again the code commit plays the role for the deployment of the code. The again code build, which will do the deployment part. Now this whole thing here was the training and experimentation, but this whole thing here is the deployment part. Once you have that, it kind of goes to AWS CloudFormation, which deploys all your code commits or all your models that you're creating. That kind of starts with your SageMaker endpoint. And then once we have the approval here, which is a manual approval, it goes to production. And that is again another endpoint wherein you hit the API, and that's how it serves your model or serves your application that you're working on. So this is a bit detailed version of how a CI/CD pipeline looks from the software or from the services kind of point of view. And then now that I have talked about so many say small services, I wanted to give a quick go through of what are the other tools or things that we can use in deployment. So a quick run through of how we go through the modeling again. We package things, then we scale them out, and then we tune the hyperparameters, some of the experimentation and monitoring there, and then the automation part, the CI/CD pipelines that we talked about. And here are the tools and platforms that I would talk about at the different stages. So first one that we talked about is packaging. You usually use Dockers or Docker images to build our models into one image. And then, of course, they being more independent and robust, and that they can be used on any platform, it's more easier for us to use Dockers and Docker images. It's very easy. You have one Docker file, and then you create an image on the basis of that. You can store data, you can store all your repositories, you can store libraries in there, and then create a Docker file with which kind of in return creates a Docker image. Once we have that, we kind of use Kubeflow, which helps in creating that pipeline that we talked about. Of course, these are few of the softwares that I'm talking about, few of the tools that I'm talking about that I use. But there are other, that you can use. There's AWS SageMaker, there's GCP, there's Microsoft Azure. So there are so many of them. But here are a few that I like to talk about. So that's another one. Kubernetes is, since we talked about Dockerization, Kubernetes helps you in putting all your images or all your Docker files, into distributed format. So it kind of creates your pods and distributes your Docker images and then runs them parallelly, actually. And then comes CI/CD pipelines. The way we talked earlier are some of the CI/CD pipelines that we talked about. We have some of the CI/CD pipelines mechanisms, and which are easier to make using, say, AWS or GCP or Microsoft Azure. And then there's Grafana, which is used for monitoring and checking. So this is, I think, it has got a great UI, kind of gives you a feel of, and it tells you can add your own features, and you can add your own parameters that you want to monitor in. But Grafana is another monitoring platform that we can use. And then ML Flow helps us in tracking the experimentation of what we are doing in our models. So ML Flow is more about, once you have the model, you kind of try and make it better and have different experiments. So ML Flow mostly helps you in keeping track of your experiments and helps you keep track of which of your models is performing best. So those are a few of the tools and platforms that I wanted to talk about, and some of the end-to-end pipelines. Now, if you guys have any questions, I can quickly stop sharing so that I can see if there's. Sure. So that
Sorry.
was.
Thank you, Ashwini. Thank you for the talk. That was really a very energetic and very informative talk. I really appreciate that. Okay, we'll now take questions from our participants. Then once the question pop up, I'll read out the question to you so you can answer them.
Okay.
For now, there's no question, but maybe I would like to ask you a question from where I learned in the talk.
Sure.
So, from your own experience as an MLOps engineer, do you see a trend of moving away from the manual to the automated, or is it a function of the kind of experiments you're working on, or the size of the company? So what do you think?
Well, there are different, I would say there are different parameters, or there are different aspects to it. First one, yes, the size of the company does matter to some extent, I would say, because so if it's a small company and the data is still coming in, if there's not a huge, like if it's not a huge data set, then I don't need to scale it a lot. That would be kind of a waste of resources altogether. If something can be done on, say, a single machine, why try a GPU if it can be worked? So that's one thing. So yes, size of the company does matter, but at the same time, the other thing is, what's your agenda that you're trying to serve here? Because what happens usually is there are so many big, buzzwords that we have in MLOps. We have AWS, we have GCP, we have, say, Azure, we have Kubeflow, MLflow, and then there are things coming in, weights and biases. So there are these so many tools and platforms that people are using. It's more important to see what is the purpose that we are serving. AWS is great, but if that is not something that that you do not want to work on automated, since you have small data, then you can go with manual. At the same time, I feel that it is very important for companies to move to CI/CD pipelines, because yes, they kind of give you this. No matter which platform you use, you use AWS, GCP, or Azure. That's perfectly a personal point of view. But I feel that it's important for companies to move to CI/CD pipelines because the automation is much easier. At the same time, I feel the downside of it is everything is so automated. Like so you feel that, do we need machine learning engineers here, or can it be done using, because I have been seeing this new auto ML thing, which kind of does everything for you. It kind of starts with data collection. I think so. Once you let it know the problem statement, it kind of starts with the data collection, gives you the prediction out. There are few things that I am working on in this domain. So size of the company, maybe the agenda that you're trying to solve, the purpose, the problem that you're trying to solve. And third is, of course, it's easier, it's better to go to automation. Of course, it's easier, but at the same time, we want to see how much of the human brain do we need, and how much of the machines do we want to be involved in our problem. So as I said, yes, CI/CD pipelines are great. They are doing the automation, which is great. But at the same time, how much do you want the machines to be involved, or how much of auto ML do you want to be involved in your pipelines or in your particular domain? That's how I look at it.
Oh, that's good. Thank you so much for that. We're still waiting for others to ask questions, but I'll ask another question. Uh, MLOps is still like a new field in machine learning engineering. And most people want to break into MLOps, right? And once you get to the gate, you see there are lots of options, lots of tools to learn. So is there like any advice on a particular tool to focus on for someone that wants to break into the field of MLOps?
Well, I feel that it's there are two different things to it. One is the breadth of the knowledge that you have, and second one is the depth of the knowledge that you have. I
Right.
feel that it's important to know the breadth of the tools that you have. So yes, you should, and that's how I look at it. It's important for you to know what a particular thing does. So, for example, I should know what AWS does, what AWS code commit does, what AWS build code does, and that's one thing. But I don't think at the same time, talking about GCP or AWS Azure, it's more important for me to know how to create an instance, how to create a VM, which are few basic things. So I think it's more important for you to have, for everyone to have, a basic overview of what things do. Once you get into company, as per the company requirements,
Right.
we anyways get used to we anyways get the deep knowledge about a particular thing. So for example, if I am looking at a company who who like who do not have anything, just work on say manual processes, then it kind of helps me. And then the other thing is, if the company is using say AWS, just knowing that what a particular thing or a particular service in AWS does is helpful for me. I do not need to go deep in there and know every single command or every single syntax. I feel that people learn it while they are using it.
Okay.
So if
Yeah.
you have, say, I would say one liners or say an overview of what a particular thing or a tool or platform is used for, that is great. You'll eventually start learning more about them when you start working on them.
Thank you. Thanks for that. That answered my question. I think we will still waiting for questions.
Mhm.
In the absence of questions, do you mind maybe including your LinkedIn or email on the chat
Okay,
in case
sure.
someone wants to reach out to you for a follow up on the talk or maybe connect with
Mhm.
you? So while you're doing that, we want to thank all the participants today for taking part in this the last part of our program today. Thank you for and our sponsors too. Uh, in the absence of any further questions, Ashwin, want to thank you for the talk, and then hopefully we get to see you again. And I wish you well in your career. Okay, thank you so
Thank
much.
you.
Okay, bye.
Sure. And I have my LinkedIn in the chat. If anyone wants to reach out, I would be happy to talk.
Okay, no
In
problem.
anyways, yeah, cool. Thank you.
Okay, thank you, and have a nice day.
Have a good one, everyone.